Hello everyone. I want to discuss section 11.2 on electrolytes. The learning objectives for this section define and give examples of electrolytes, distinguish between the physical and chemical changes that accompany dissolution of ionic and covalent electrolytes, and relate electrolyte strength to solute solvent attractive forces. So, you have probably heard of electrolytes, specifically from uh, commercials for sports drinks. Um, and it sounds like a really complicated word that must be really important. It turns out it's not that big of a deal for something to be an electrolyte. Um, when something is an electrolyte, what it means is that when it dissolves in water, it breaks apart into ions. Okay, that's what it means to be an electrolyte. Um, if something dissolves in water and does not break apart into ions, then it is called a non-electrolyte. I want to emphasize that both electrolytes and non-electrolytes are dissolving in water. The difference is that the electrolytes are breaking apart, whereas the non-electrolytes are not breaking apart. In fact, I think a great example of this was actually shown in section 11.1. You might remember I said we would discuss this later with these two reactions showing something dissolving. The first one, we're showing sugar dissolving, so solid, and then it dissolves to form an aqueous solution. This one is a non-electrolyte. It is not forming ions, but it is still dissolving. Here we're showing potassium dichromate dissolving. It is forming ions. So we see we have positive charges and negative charges. So it is forming ions. So this one is an electrolyte. Okay, so electrolytes break apart into ions. Non-electrolytes do not break apart into ions. Let me go back to 11.2 and we'll discuss this a little bit more. So based on that definition, you might believe that ionic compounds are probably going to be electrolytes, and you're right. When an ionic compound dissolves in water, it is always breaking apart into ions. So all ionic compounds are electrolytes. Some molecular compounds are non-electrolytes, and some are electrolytes. We're going to take this idea of electrolyte and then break it down a little bit farther into two additional categories. Some things break apart 100%. Every single molecule ends up as ions. If that happens, we call that a strong electrolyte. And if it doesn't happen, if some smaller amount of them break apart, but not all of them, we say that we have weak electrolytes. Again, all ionic compounds are strong electrolytes. For molecular compounds, some of them are strong electrolytes, some of them are weak electrolytes, and some of them are non-electrolytes. We're not going to get too deep into figuring out all those molecular compounds for now, but you do want to have a pretty good understanding for ionic compounds because when they break apart 100%. So let's talk about some properties of electrolyte solutions. When we have an electrolyte solution, that solution will conduct electricity. So we can test this out by putting a circuit that goes through the solution. So you plug something in, one of the wires goes to, say, a light bulb, the other goes into the solution, and then you see if it conducts electricity. Please do not try this at home. It's a very dangerous experiment. So don't try this out, but this is the way it would work. If you have a non-electrolyte solution and you do this, you get no current at all, and the light bulb would not turn on. If you have a strong electrolyte, you get a very high conductivity. The light bulb turns on all the way. And if you get a weak electrolyte, you get a less of a conductivity and it only turns on dimly. Um, you don't have to know why these particular substances have, the electrolyte properties that we're showing. So don't worry about that. One thing though you might notice is that here we're showing positive and negative charges. Here we're showing nothing with positive or negative charges. Here we're showing positive and negative charges and some that have nothing. Okay, so the weak electrolyte is a mix of things that are not charged because they didn't break apart, and a mix of things that are charged because they did break apart. So let's talk a little bit about what happens when an ionic compound dissolves. Um, so the process here of ionic electrolytes involves something called an ion dipole attraction. So if you think back to Module 10, we had a series of intermolecular forces like dipole-dipole attractions, hydrogen bonds, dispersion forces. Ion dipole attractions are similar to that. So it's similar to a dipole-dipole attraction. The difference is instead of two dipoles being attracted, you have a dipole attracted to an ion. So basically what's going on here is that the ions can become surrounded by water molecules, which have very, with the hydrogen bonding, have very strong attractive forces. So the portion of the water molecule with a kind of partial negative will be attracted to the positive charge of the ion, whereas the portion of the water molecule with a partial positive, the hydrogens, will be attracted to the negative charged ions. These are very strong attractions, and they're strong enough actually to pull apart ionic compounds, which we again learned in Module 10 have very strong attractions. So their attractions are strong, but they're not strong enough that they don't get pulled apart when put into water. So this process is called dissociation. When a substance is pulled apart into its ions. For some covalent compounds, we also have this process that can occur. And again, we're not going to get too deep into this, but here we're showing an example of that, where we have water forming hydroxide ions and hydronium ions. So that's one example. Other things and this one is a weak electrolyte. So about 2 out of a billion water molecules will do that. So we would say it's a weak electrolyte, even we would say very weak electrolyte. But other covalent compounds will break apart 100%. So here we're showing hydrochloric acid breaks 100% apart into chloride and then hydronium. Okay, so this is a strong electrolyte. When this happens, and one of them is hydrogen, we call this a strong acid. So that is it for section 11.2 on electrolytes.